Good day. I am Afeez Alimi Olalekan. This project is brought to you by OSIS InfoByte. I take on this task as one of the projects I attended to during my internship. This project is all about house pricing prediction modeling. There are some criteria that are looked into when planning to get a house or an apartment. The price involved. These factors could include the area in which the apartment contain, the bedrooms that are in that apartment, number of bedrooms, bathrooms, the maybe it is two-story building, three-story building. Is it located at main road? Yes or no? Does it have guest guest room? Does it have other amenities? Does it have parking space? These are things that might be looked into. And which is the house or apartment in a preferable area? These are questions that might be asked to know how well the housing price will be, if it is costly or it is of less price. Now let's delve into this. Now the first step is importing the libraries. Libraries used here, I make use of linear regression as the modeling, the machine learning algorithm for modeling, training of data sets, and testing of data sets. Now let's delve into it. The first thing is import pandas as PD. Yes, this is used to manipulate the data, to import data and all sort of things. Now same thing, data part equals this. Then using the pandas that we imported, data equals pd dot read csv, then data part, data dot head is to show the first 5 rows of the data set. Now this next cell, this cell 2, is to show the shape, data dot shape, to show the shape, the rows and column. We have 545 rows, then 13 column here. So this info is to tell us to view the to give us the overview of what is going on in the dataset. We will clearly see that we have 544 row entries and none is null. We have no null values. Can you see? You have no null values. So that's that. So describe is just to give us some statistical view, the count, number of counts, the mean, standard deviation, the spread of data, how well the data spread, maximum, and the rest. Now, to check for duplicates, data does duplicated, then does sum will show us the number of duplicate entries we have, and we have none, which is 0. So the comment here is that no duplicate in the data set, no null values in the data set. Now, the questions, there are series of questions that might be asked, that might be looked into when analyzing this data set. One of which I did is, how does numbers of bedroom affect house prices? Now, using the group by method, bedroom will be inside a group by data dot group by bedrooms. Then the price, we want to check the price by sum. The action taken on it is sum. Then reset index. Now I said it in my first video that I like using this reset index because I will not be using my matplotlib library to be naming to label the x and y as instead of using plt.x label, plt.y label. I don't do that again. Just this reset index will help me do that. So then sort values by price. That is, we are sorting it by price. It should enable us to have it in ascending order or descending order. So ascending order here is first, means it will be from the top to bottom. But if it's ascending equals true, that means from the lowest value to the highest value. But here we want it from the highest ranking to the lowest ranking price. So you can say that bedroom apartment with 3 bedroom have the highest price. It has more value than those with 4, 2, 5, 6, and 1. Now, to make this on a chart, on a bar chart, importing the matplot libraries to just to show to use the line of code plt does show, but in this case it's not really needed. What I need is the cbon. Import cbon as sns, then sns dot bar plot, that's the kind of plot we're doing here. X is stated as a bedroom, which should be the x-axis. Y is the price. Then the data we are using is this data. The output here is data which you have sorted. So now the chart is here. You see the reason I said it is easy for me, but the only the only reason I will need plt is when I want to give it a title. For example, plt, let me, it will be after this code, after this line of code. Plt dot title, that's when I'll need it. Then I'll give it a title. That's bedroom, bedroom, number of bedrooms, number of bedrooms versus price. Now plt dot show. Can you see? So that's only when I need the plt the show, but I never used it in this case. I never used it, only during this um recording. So this, if you see it here, that we are getting the true picture of what the data frame is giving us, the output. Now, other sets of questions were asked: how does number of bathrooms affect house price? And we see that house with only one bathroom has more value. So then, how does numbers of stories affect house price? Number of stories, 2 stories, it has more value than others. So did the same to others. Main road, that is, yes, here have means the house is in the is in a located in a good area, that is main road, not in a far place or far distance place. This no saying that it's not in main road. That's the difference. And you can see difference that main road apartment has more value. So how does guest room affect house price? The question were asked and done. So the rest are the same to this. How does hot hot water heating, that is, this is one of the amenities that some houses has. So air conditioning. So these are things that are in the data set that were looked into. How does parking space affect house price? Is there how many parking space? There are some houses that don't have parking space at all. Maybe the house is very big and and they don't have parking space. Some house might be small with enough parking space. I think this was cause this. So this is one of the reasons why houses or apartment with with no parking space are more costly. Maybe they have enough space. These are things that are looked into. How does preferred area affect house price? Preferred area. When you say preferred area, that is where you like. You might see a house that you don't like, then you don't that think, this area is too expensive for me, and These are some reasons that or some factors that might affect apartment price. So now let's go into the training, testing, and creation of model. Now, to train the model, we need a machine learning algorithm. The one used in this project is linear regression. So from sklearn linear model, this is the library, the where the linear regression is coming from this library. Import linear regression. Now, another element that was imported from sklearn is train test split. From sklearn.model selection, import train test split. This line of code is to split our data sets into training and testing part. The X part, which is the independent variable, and the Y part, which is dependent variable, we split it into training and testing with a test size of 0.2 or 0.3 depending on how we want it. So this here is to check the accuracy, the accuracy. So it's the metrics used in machine learning in training datasets. So from sklearn.metrics import, we have different metrics. You can use mean square error, accuracy score, and its likes. So let's continue. So in this case, there are some categories in this dataset that are not numerical. For example, the main road, yes or no question, which is saying that is it in main road or not, yes or no. Guest room, we have yes or no. We have basement. You can see here in this column basement, you can see that it has a no option. It has yes option. So these are categories, categorical data that are not numbers, so we have to convert them. So wherever we have yes, it will be 1, and wherever we have no, to be 0. To make it easy for training and testing. Now that's what the next line of code is doing for us. One auth encoder. So we are importing that from this library sklearn.preprocessing to preprocess the data into preferred numerical format, which is whereby you have 1 when you have yes and 0 when you have no. So now we initialize the one not encoder here, giving it a variable equals one not encoder, then spouse output equals false. Now here the next line of code here is now is to fit transform, to transform it. So encoder, this is the encoder here, this encoder is what we have here, encoder dot fit transform, to transform that. These are our columns, categorical columns. So we are transforming all these categorical columns to a better format which can be handled by the machine learning algorithm you want to use, which will be able to be handled by the machine learning algorithm, which is the linear regression we are using. So this is converted to an array. As you see, this the output is an array of numerical numbers. So whereby we have, when we have yes, it will be 1. When we have 0, is no. So now converting to a data frame. So this is encoded data frame is the variable I give it, equals pd dot data frame. Converting to data frame, what is the features, the encoded features? These are the features. These are the features here. The outputs here are the features, which is not in table in a data frame. It's just an array. So putting in the data frame to be pd. You know I said pandas is used to manipulate data. So pd dot data frame, the features is encoded features. Then comma the columns equals encoder. This we are getting the column from here. You know these are this is the column names. This is the column names, encode categorical columns from the data. So encoder dot get feature names out is like writing English. Get feature names out of the categorical columns. That's the interpretation of this. Then this one is giving us the first three rows. That's that. The next line of code here is that we have to drop the whole categorical columns where we have the yes or no and the rest and its likes. We drop it. This is what this one is doing. Dropping it, then we concat. We concat the new column and the main data after dropping that, because if this is done first before doing this, it is not good at all. The first thing is to drop the old categorical columns, then we concat the data, the new data with the new encoded data frame. Now that's that. Then we want to create the x and y variable. The x variable are the independent variable. They are determinants for what the output will be. So the x now equals data dot drop column. What the column I'm dropping here is the price, because the price is the target value. It is the output of what we need. So to ease the stress of mentioning each column, I just drop the column, so remaining the independent variable. Now for y, we just have to call the price. Y equals data, then the price. This is a list. That's why you have y square bracket. So this here means 0. That's the starting point. Then 5. 0 to 5. It will just count it. You know, in Python, the first index is 0. 0, 1, 2, 3, 4. That is going to stop. The 5 is not going to count. That's the last, the ending point. So if we want the fifth value, we have to change that 5 to 6. Let me do that here. Let me do that here. Can you see? So that's it. Now let's move on. Now we want to train, we want to split the data set. We have the x and y value already. So now you bring in the x train, x test, y train, y test equals the train test split that we imported from the data preprocessing, from the model selection rather. The train test split that we imported from the model selection, we have to use it here to split our data set. The train test split that we imported from the library sklearn.model selection. So we have to use it here. Train test split. What are we splitting? We are splitting our x variables, that is the independent variable, and the y, which is the target. Then what is the test size? 0.2. We can use 0.3 also. If we are using 0.3, that means our training set will be 0.7. But in this case, test size is 0.2. That means our training set is 0.8. Then model creation. We have our model from the linear model, sklearn.linear model. So model equals linear regression. We are we are creating an instance of the model here. Then model dot fit. We are training it here. This is where we train the model. X train and Y train. Can you see the output? Now we want to evaluate, we want to test how well the model is performing. So using the model, from sklearn.metrics, we are using that mean square error. So predictions equals model dot predict. What are we predicting? The x test. So then the mean square error equals mean square error, then y test, and the predictions. This is the predictions. So this is the outputs. Mean square error is this. So the to get the feature importance, that is the features that are needed, the most important features from data sets, that's why we need this from sklearn.linear model import lasso to get the feature importance from data set. This line of code is important. So From the line of code, this is the output. Bathroom is the most important feature, is the most important, followed by air conditioning. That is when there's no air conditioning, people they prefer that because of the price. Hot water heating, if there's no hot water heating. So these are some features that are more important to some people when sourcing for house. So that's all about house prediction modeling.